You're there. All right, so this week we are going to be kind of working on data. Like really, I like to call it conditionals. We're going to work a lot with conditionals, but data fabrication as well. It's actually one of my favorite weeks. And what we're going to do is we're going to walk through the exercises, basically kind of what we're going to use to learn it. Because I feel like some of these exercises actually do like a really good job of kind of showing basically how we can go about using these case statements to do some really cool things. So anyways, that's what we're gonna do. And I know that someone had a specific question about it, so we are going to cover that as well. All right. Let's see where I put this window. So I'm trying to find, there it is. All right. All right, so these are our exercises here. And you'll see that, we kind of have like a couple of topics, but mainly around these case statements. So anyways, we're going to kind of just start, we're just going to dive right in, and go through some of these test cases and learn how to use them. Because there's a couple different ways. And what I really like about these exercise questions is they really kind of step through like, oh, here's a basic use case. But then we kind of get into more some kind of analytical use cases, which is really nice as well. So anyways, the first question is we should rewrite the following query, which uses a simple case expression so that the same results are achieved using a searched case expression. So yeah, those are the two definitions of a case statement. We have our searched case and our simple. And I'll be honest, I rarely use a simple case statement. Most of the time, I go straight for a searched because it just makes things easier when you need to all of a sudden decide that you want it to be searched, essentially, which tends to happen quite frequently. Anyways, let me get this set up here. Let me delete this extra stuff, and then we'll talk a little bit about what's going on here. So basically what's going on is we can, let's just run this real quick and then we can start there. So basically what this is doing is you can see the name, and then we're basically fabricating data. And what I mean by fabrication is we're not pulling it from anywhere. We're actually deciding what we want this to be. So we can see when it's English, then we're going to do Latin 1, when it's French, Latin, so on and so forth. But if it's Japanese or Mandarin, we're going to use UTF-8. And then if none of those are true, we kind of backstop that with this big unknown. So this one is a simple case statement. And what makes it simple? Because we say case and then variable. And then we just say when this, then that, when this, then that. And we kind of go through it. So what we're going to do is we're going to rewrite this to be a searched case expression. And basically what searched means is we get rid of this and we come up with our own kind of logic here. So we say when name is equal to English, then Latin 1, and so on and so forth. Now, what I'm going to do is I'm actually going to get a little creative and kind of use some of this to our best ability here. So we're going to clean it up a little bit, because we could just go through here and say, when name equals this, name equals that, this is kind of like the easiest solution, right? We just paste these in there and then we can run this and it should work just the same, but it's a search case. But what I'm going to do is I'm actually going to make this a little easier so we can actually see the power of why we might want to use the search case. So instead of using equals, I'm gonna say in, and I'm gonna say, okay, when name is in, I'm gonna say English, Italian, French, German, then Latin 1. So, we can basically search cases are just a lot more powerful in the sense that you can build logic. You can use and, you can use or, you can use in, you can use all these things just like you would like any kind of logic. Whereas a simple, you can't. It's basically once you put this here, it's just got to be when value, then new value, when value, then new value. So anyway, there's question one, and hopefully an explanation of the simple versus searched. All right, this is one of my favorite ones. This is when we start to get like really nifty with our case statements. So this is one of my favorite things to do, and when I use case statements the most is actually for stuff like this. And so let's start with just so we're selecting rating from film, basically. So let's go down here, let's add a bunch of lines. We're going to select rating from film. Let's run that. And we can see all of these ratings. We can see a bunch of them. We could shorten that up by just saying select distinct. So here's our ratings. Now in the example, what they do is they say a count of everything. So instead of saying select distinct, we do a count, and then we group by rating. So basically what we end up with is all the ratings and how many movies are in each one. And we can see that those same kind of values right there, 178, 194, etc. But you'll notice that we have ours in where the ratings are rows, but we want to pivot that into columns, right? And there's a lot of reasons why we want to do this in a lot of different situations. But this is, I guess a good intro to that end. So what we're going to do is we're going to keep it just like this for the most part, but I'm going to get rid of rating here. And when I get rid of rating there, you'll notice that we just now, we still have our groups. But what I'm going to do is I'm going to build, and in fact, we can get rid of this as well. Let's still just select everything. So we're going to kind of back up cleared here. So we have 1,000 movies. But what I'm going to do is I'm actually going to put a case statement in here. I'm going to say case when rating is equal to PG, then film ID, end. I'm going to say as, let's call it PG 13. Right? Something like that. Now, when I run this, you'll notice that I get my PG 13. And now what I can do is I can take this, and what's our ratings here? We have G, PG, PG 13, R. I guess I should have started with the lowest. G, this one was R. I'm still missing that. PG, R, and then an NC 17. From film. And there we go, just like that. Now what's cool is we can make this G, we can make this a PG. Might as well make it clean so it matches. There we go. So that should get us the same results that we see there. one row, we basically just pivot it. So you can see how you can kind of use these case statements to select a bunch of different things. And what I really like about using this trick is then you can build a bunch of different metrics actually kind of all along with each other. Because we can do a bunch of different things where you can, just like this, we want to get counts of movies across a variety of different things, but it doesn't just have to be movies. We could get, how many PG movies were there? How many, how much revenue did PG-13 movies bring? All this stuff, kind of have it all in a given line, which is kind of neat. So there is question 2. All right, question 3 and question 4 are a lot alike. And in fact, it even kind of rolls into question 5. But the way that question 3 starts is it wants us to write a query that returns the alphabetized first letter of the customer's last name, and then the count of active and inactive customers. So anyways, let's kind of use this as our basis. So let's go here. And we're going to get a count of all of our customers as a start. All right, so there's our count of customers. Now what I want to do is I also want to make it so we can just get their first initial of is it their last name? I forget already.
Yep.
Starts with
their initial, their last name.
Okay, yep. First initial of their last name. So what we're going to do is we're going to use a function here. And we're going to call a letter, sure. So there we go. We can select distinct and boom. So with this function, now we have everybody's first letter of their last name. And this, yeah, so this is kind of like our starting point, so to speak. So now what we can do is, so we have the letter. And then what we want to do is we want to get the count of active and inactive. So again, we're going to use this trick. We're going to say case when active is equal to 1, then customer ID, and we're going to call this as active count. And then we can basically grab this. Say group by, and then we just paste our, not that one. Group by the letter of their name. And we can run this, and there we go. So now we have our letter, our active count, inactive count. We're still out of order. So I'm going to say order by 1. And there we go. So now we should have our list. And that is question 3. Now question 4 gets a little bit more interesting because now all of a sudden it wants us to use all of the 26 letters of the alphabet instead of just what there are customers for. So that's where this data fabrication comes in. A lot of times, we want things that don't exist and we don't have a place to pull them from. So like in this case, you'll notice that we're missing a Z. And a lot of times we want to be thorough. We don't want to just not have a Z. We want to see Z and 0. Because sometimes it's real important to not leave data out, when you're doing a lot of these analysis. So what we're going to do is we're going to fabricate a table. You'll notice it says you need to fabricate your table. So what I like to do is I like to open up a code editor. So let's do, I'm going to open up just Visual Studio Code here real quick. And what I'm going to do is I'm going to just type in and we don't even have to get super crazy with this. I'm just going to do A, B, C, D. But no, trying to be too smart. A, B, C, D, no. Sometimes, I swear.
Don't you just hate that autofill?
Yeah, it is, it really is something. Hey, tell you what, we'll. Try so hard to be helpful, and they end up just making it. We're gonna use text edit just to get started. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Y, and Z. All right, so I'm gonna take this, copy it over here. And then this is where this kind of stuff, I use it all the time. It's super handy. Basically, we're gonna look for that and then we're going to replace it with some text. So basically, every time that we see a carriage return, what we're gonna do, anytime we see a carriage return, we're gonna replace it with basically code that we want to fill in to basically fabricate this table. So I'm looking for all of the carriage returns. I guess maybe I should get a little bit smarter here so we don't end up with a bunch of garbage. And delete all these extras. All right, so anytime there's a carriage return, what I'm going to do is I'm going to replace it with a quote. And I'm going to call it letter. And then we're going to do a carriage return and say union all, another carriage return, and say select space quote. And so if I've done this right, basically what we should do is we'll basically build everything here for us. Let's see how I did. I think we did it. And then we should just be able to fill in the first here. We'll say select. Anyways, this is one of those prime examples of I don't like to type on a keyboard, so I'm gonna cheat the system. So what we end up with there is our alphabet. So I can just run this and I get the alphabet, and nice and simple. Now, a couple things we can do here. We can create a table. Honestly, I think there's a lot of value in kind of having like these utility tables around. You may laugh. I actually, in most of the databases I work with, I keep a utility table of the alphabet. I keep a utility table of numbers. Like 1 to a billion or whatever makes sense. And then I also keep a utility table of calendars. So I'll pick like a day in the past where it's relevant to whatever date I'm working with. And then I shoot way forward to like 2099 and I fill out every day, every month it's in, every year, quarter, day of the week, all that kind of stuff. Because you'd be amazed at how useful it is. Because then when you just want a date, you can just do it and you don't have to worry about using these functions all the time. You can just join it up. So I create those all the time. So in this case, we can do that as well. We can say create table alphabet as, and we can just run this. And I already have one. So it's already there, but I will drop it, drop table alphabet. There we go. And then I'm just going to recreate it. So now I have this new table called alphabet. I'm going to put this here before I forget. Drop table if exists. So now I can just easily say select everything from alphabet. And I have my alphabet. So you can do that. You can also use it just as like a temp table, like in a subquery. Bunch of different things. You can use with, this as this, and then you can run your query. Like I said, this one's utility enough. I just create it. Which is all, like I said, really handy at times. So we have our alphabet table with all the letters. And so now what we want to do is we can take our existing query here. All right, I gotta fix that before my OCD kicks in. All right, so let's grab this again. Now that we have the alphabet table, what I'm going to do is I'm going to just use our basis here, same thing. But I'm going to take this customer C and I'm going to left join alphabet A on. And this time I'm going to say, I'm just going to cut this. I'm going to say when C dot last name first letter is equal to A dot letter, then we join. And now we can say A dot letter, A dot letter. And we want to make sure we left join. Actually, we need to do this. So I could switch these around. This is a good use case example for when right joins are even useful. So if I'm too lazy to swap these around, I can do a right join. And you'll notice that we still got we get our Z with the 2 zeros. Or I could just take these and say, you know, hey, I want to select this from alphabet A and then left join customer C. It's the same thing. You know, one, you just swap it around. I don't like right joins because mentally it's easy for me always to like lean left. And so I tend to do that. I read left to right. So for me, when I'm reading code, I always like to use left joins. I never use right joins. So anyways, so yes, that's how we get exercise question number 4. It's just like that. Cool. Yep, and the counts are exactly the same. All right, so now what it wants us to do is it wants us to write a query that returns the alphabetized first letter, blah blah blah. This is the same thing. But the only difference now is that it wants us to get it only where the letters only the records who have an active count of customers greater than 30. And so this is actually really simple. Question number 5 is the easiest of them all once you've gotten there, because if you've done everything right up to this point, we know that there's this fancy little clause called having, and we can just say, hey, you know, if you have an active count greater than 30, is it greater than or greater than equal to or greater than 30? Then we can just do this, and there we go. That's simple. So we just use the having clause to get a count, limit it to 30, and boom, we're done. Cool. These case statements are really fun. You use them all the time. It's one of those ones that if you're going to learn anything in this class, learn case statements, because you use them all the time. And especially it's kind of funny because like looking back, it took me a really long time to realize that you could do this. You know, I was never really taught this. The case statements inside of an aggregation are like these neat little hacks to basically filter inside of an aggregation, you know, to aggregate. So you can like do 3 different types of aggregations without having to build 3 whole different queries. You can kind of pick and choose what you want in here. So anyways, it's really cool. I would recommend playing with it a little bit if you so desire, have the time, because they're a lot of fun. But anyways, that's all I got for the week. Do you guys have any questions? Anything you'd fuzzy still?
So I have a question.
Yep.
So in like kind of like the videos that we had for this week, he did like sum instead of count, and he explained why he did it, and I was like, okay, that makes sense. But in your then you use customer ID.
Yeah,
He
so
had like active
this is
equals 1,
this is
then
where I'm
0
gonna
or something. But
yeah,
why
this is
use
where I'm gonna
customer ID?
differ from a lot of, well, not differ from a lot of people. I'm going to differ from the content because a lot of people will want you to do like this, where, like you said, instead of doing a count, you do a sum,
Yeah,
and instead of doing customer ID, you do one, right?
yeah, or like 0 or something, then 0.
Yeah, exactly. Yeah, so you basically sum it. So like in this case, it's the same result. The only difference is that, I'm summing numbers instead of counting things. Um, the reason I use count is because a lot of times in the data, when I'm looking for, I mean, because I certainly sometimes will use count, I'll use count and sum, like if I'm looking for total revenue, right?
Right.
I certainly will. Like, you bring up a good point. Let's, because we got a couple more minutes here. So, this is a good example of a use case. So I'm going to look inside of our payments table. And this is the world I live in. Analysis around money is like my jam. So, and KPIs. So like, this is a prime example of why I like to use count, and not the sum. And here's why. So like, let's say that I want to summarize my data and I want to do it by year and month. So let's start there. I'm going to say, I want the year from payment date as year, and I want the month of payment date as month. And then what I want is I want to see, let's just start off with the sum of amount. And this is what we're going to call revenue. As revenue. Right. So here's our basic query. I'm going to group by. Let's grab these two things. Boom. So anyways, there's our year, our month, and our revenue, right? Nothing too crazy there. But what I want to do is, let's say I want to start separating this out by, hey, we have all of these transactions essentially. What I want to do is I want to know, in each given month, year and month, like how are people spending their money? Are they coming in and renting many movies? Or are they coming in and renting one movie? And there's a lot of different things like we could kind of glean out of this. And so I'm going to build a few different KPIs and then we can talk about it. So what I'm going to do is, first of all, I'm going to decide on my bins. So I'm going to select distinct amount from payment. So anyways, there's some of our amounts. I see like a 99 cents, and then I see something upwards of 11.99. So 99 cents to 11.99. So what I'm going to do is I'm going to, like, normally like there'd be more sophistication around this as far as like, oh, how do we want to do this? But what I'm going to do is I'm going to say, okay, yeah, I want to say, okay, how many, I'm going to call this revenue underscore, let's do 99 to, let's just call it tier one, revenue tier one. And we're going to say case when the amount is greater than, or let's just say less than, let's call it $4. We're just going to play with even numbers. And then I'm going to take and copy this. We're going to say when amount is greater than or equal to $4 and amount is less than, let's call it $8. We're going to call that tier two. And then the last one's going to just be anything $8 or above. Greater than or equal to, then it's going to be revenue tier three. So we can run this. And now you can see that we're now starting to split up to see like, okay, like which tier is giving us the the best bang for our buck here. And then furthermore, we could even build out a couple other metrics, because let's say, we want to keep this in the year month kind of category, right? So, I mean, we could just build out the tiers this way, but some other way, but we're gonna keep this kind of theme going. So this is where I like to use count, and it's so I can do this. I'm gonna say count distinct, and I'm gonna say case, and we can just use the same one. And basically what I'm gonna do is, instead of counting, if you were to use sum, you can't get a distinct count, which is oftentimes what I want to use. I want to see like, hey, like how many unique customers did X, Y, or Z. So in this case, I'm going to count distinct customers, and I'm going to say, as customers tier 1. Basically, how many customers did we have in tier 1? So this is how many customers. And then I can even take this a little bit further and say, hey, I want to now see not just the customers, but how many rentals. So you can kind of see like I'm starting to like layer this on there, and I could like build this all the way across. So we have like how many customers, how many, this is how much money we made. This is how many customers came in. This is how many rentals they had. And really, this is how I'd like to see it. So let's, I may just take out tiers 2 and 3 for right now, just so we can see. And then this is what I like to call funnel, where basically you kind of like, because like, let's say we're a business and we want to monitor these KPIs, hey, the first step is like, how many customers do we have walk in the door? How many rentals? How much revenue? And then, then we could start to build like a couple things like even before we hit revenue. We could say like, oh, I want to see what
Like
are
the average or something.
yeah, like how many, yeah, exactly. Like we're gonna start kind of getting into that, like what on average, what's our rentals per customer? For tier 1. Where did I mess up here?
You have a comma after on 56.
Oh, yes, I do. Thank you. There we go. So now we can kind of like see like, oh, like within this price range, how many times, like when they came in to get a movie, or in that given month, how many times did the customer come in on average? And so we can see like, oh, July was like a fantastic month for tier 1 rentals, because we had a ton of people come in, and then obviously then we can run like our averages to say like, oh, like what is the, now that we have our total revenue, what's our average revenue per customer?
And can you use instead of sum like the average?
Well, you
Or no?
could, but again, you would get the average of the amount, not the average of the sums, if that makes sense.
Okay.
Yeah, so like average works really good, like when like we get the average price, but really what we're gonna do is we're counting different things. So if we did the average, we get the average price per transaction. Where in
Okay.
this case, we want to say like, hey, what was the average price per customer? And then, furthermore, we could do the same thing, but also get the average price per rental. Which are different things, because then the last step would be to say, hey, what's our average transaction amount? Which then, just like you said, then you could run the average. Just like you said. But here we kind of have like our full funnel, where now we can say like, we have this by tier. So this is just our tier 1 between, basically under $4. So for all the people who had a transaction under $4, we can say, hey, this is how many customers had a transaction under $4. This is how many rentals were under $4, total rental in the transaction. So then we can see our rentals per customer,
Mhm.
our revenue per customer, our, no, what was that? Oh, this is our total revenue, then our rev per customer, and then our rev per rental. So you can see like, yeah, just like this, we had, obviously the more times a customer comes in, they're gonna spend more money. But
Mhm.
obviously, like if they came in 3 times and only rented a 99-cent movie every time, doesn't necessarily mean anything. So the rev per customer is actually a nice metric, and then also rev per rental. So we can actually see, on this one, even though, like this is great, we actually had higher rev per rentals here. The difference is that the amount of times they came in. So like they came in less times here, but they spent more money every time they came in, essentially. They just came in less. So, that's interesting to see. I mean,
Yeah.
I don't know much about the movie theater, but the movie rental business. But that's where like I really love these types of little hacks because you can very quickly build these KPIs, because we could do this for tier 1 and then just layer on tier 2, tier 3, or whatever. Or if we just wanted to say, hey, this is for tier 1, but just how did we do overall? And so then you can like build these layers, like where you say, oh, here's how we did overall, but then here's little segments of the data. And so then when obviously there's ways to make this pretty, but you have to get the raw data out somehow, and this is how. Because once you get it here, then you could throw it in like a Tableau or any of these BI platforms and really make it look cool, essentially. Cool. Yeah, great question. But the main reason, I guess, to circle back to the original question before we went off at a tangent, I like to use count whenever I'm counting things. Like if I'm looking for, hey, how many inactive customers did I have? I really don't like the idea of summing because there's so much room for error.
Okay.
Whereas, because we don't always know. I mean, in a lot of database systems, yeah, like if we're counting contacts, yeah, maybe, but maybe we're in a data set where there can be duplicate customer IDs. Like maybe the way we've joined our data. So I always like, if I'm counting, I stick to count. And if I know, like as safeguards, usually I always put count distinct unless I know there's a reason not to. But like if I'm counting IDs, I always do count distinct. Just as a safeguard, because and then also it gives me this freedom where if I wanted to layer on another set of data, like in this case, we're counting transactions and we can see right here that there's multiple records per a single given customer. So that's kind of like my own moral compass rule, whatever you want to call it, is if I'm counting things, I use count. If I'm dealing with numbers and I'm summing things, I'll use sum. And that's just my own personal rule book. So, I mean, do as you will. I in the videos they use like the one and they sum it, but
Yeah.
to me that's like it's faulty. It could
Yeah.
potentially be faulty. So I don't like to proliferate that because then when someone goes to do it once and it's like not working, anyways. So count
Yeah.
when you're counting, sum when you're summing, and yeah.
Okay. That makes sense. I mean, yours is like, yeah, compared to what I did. I was like, yeah, I made mine a lot more complicated.
Yeah, no, that's what I found. A lot of this stuff is like because there's lots of different ways to skin the cat, but usually there's an easier way. So anyways,
Yeah.
no worries at all. But all right, any other questions?
I was wondering if you could paste in your alphabet table so that I can keep it in mind.
Yes.
Okay. I was like, that's awesome.
Yes, I'm glad you asked. I usually do that. So then you don't have to do it. There it is.
Thank you.
All right. Well, thanks you guys for being here, and hope you guys have a good evening. If you guys get stuck, let me know. otherwise, yeah, great luck and we'll talk next week.
Well, thank you
Alright.
very much. It's good to see something work other than my attempts at trying to.
Oh, I know how that goes. I know how that goes. All right. Yep. Talk to you guys later.
Thanks.
Thank
Have a good
you.
night.
Yep, you too.
Bye.
Bye.